To find the equation of a line, a straight line which has general equation y equals mx plus c, we need to know the value of the gradient, and we need to know one point that lies on the line in order to find the value of c, which is the y-intercept of the line. So we have a gradient of 2, and the line passes through the point 4 nines. All the information we need is actually given to us here. This is just a straightforward substitution of the gradient and the points rather. So 9 equals 2 times 4 plus c. 9 equals 8 plus c. C equals 1. The equation of the line is therefore y equals 2x plus 1. Again, to find the equation of a line, we need to know the gradient m and one point that lies on the line. If we don't have the gradient, we have to determine the gradient. Now, in this exercise, we are given 2 points. So from those 2 points, we are going to first determine the gradient by the equation gradient equals y2 minus y1 over x2 minus x1. Once we have that gradient, we can then use either of the 2 points to substitute into y equals mx plus c to find the equation of the line. So the gradient will be 6 minus 0 over 5 minus 1. It's going to be 6 over 4. The gradient is therefore 3 over 2. So the gradient equals 3 over 2. We can use either point to substitute into y equals mx plus c. So we're just going to use 1, 0. Therefore 0 equals 3 over 2 times 1 plus c. So c is minus 3 over 2. The equation of the line is therefore y equals 3 over 2x minus 3 over 2. A better form would be 2y equals 3x minus 3. And this is the equation of the line passing through the points 1, 0 and 5, 6. Find the equation of the line parallel to the line y equals 3x minus 5 passing through the point 1, 7. We have a similar question in B. So we're only going to do A and one of C or D. We'll do C, since C and D are pretty similar as are A and B. So starting with A, we want the equation of a line. Okay, so the equation of a line is y equals mx plus c. I'm going to call this f of x. And the reason is we are relating it to another line, y equals 3x minus 5, and we're going to call that line g of x. So g of x equals 3x minus 5. Now, we are told that the line we're looking to find the equation for is parallel to y equals 3x minus 5. So they're telling us that f of x is parallel to g of x. The information we get from that is that the gradient of f of x equals the gradient of g of x. Two lines are parallel to each other, their gradients are equal. So we can clearly see that the gradient of g of x is 3. So therefore we know that the gradient of f of x is also 3. So f of x equals 3x plus c. Now this line f of x passes through the point 1, 7, so we're going to substitute that point into f of x. Just coming up here, we'll have 7 equals, or maybe a better way to write this, x equals 1. So f of 1 would be 3 times 1 plus c. F of 1 is 7. Therefore c equals 4. And therefore f of x equals 3x plus 4. Okay, C, we're looking for a line perpendicular to the line y equals 2x minus 3 passing to the point 6, 1. Okay, so again we're going to call f of x the line we're looking to find the equation for. So f of x equals mx plus c. G of x, we're going to call this line here, g of x equals 2x minus 3. Now, f of x is perpendicular to g of x. that means that the gradient of f of x times the gradient of g of x equals -1. This is the condition for perpendicular lines. So looking at the gradient of g, the gradient of g equals 2. The gradient of f is therefore the negative reciprocal of 2. So the gradient of f is -1/2. So f of x therefore equals -1/2 x plus c. And now we substitute this 0.61 into f of x to determine the value of c. So f of 6 equals -1/2 times 6 plus c. F of 6 equals 1. So 1 equals -3 plus c. C equals 4. Therefore, f of x equals -1/2 x plus 4. We find the equation of the perpendicular bisector of the line segment joining the points 5, 2, -3, 6, and then the points in B and C. Okay, so let's just first define what's meant by a perpendicular bisector. If we've got a line, we'll just call this line AB. The perpendicular bisector of AB is another line that will cut AB in half, and it will be perpendicular to that line. We'll cut that line at 90 degrees. So we will have a line that will cut AB at 90 degrees, and it cuts AB in half. In other words, AC equals CB. C will be the midpoint of AB. So if we have our points A, 5, 2, and B, -3, 6, then if we are looking to find the equation of the perpendicular bisector of AB, we are looking to find the equation of this highlighted line here. So to do that, we need to find the coordinates of C, the midpoint of AB. So the midpoint of AB will be x2 plus x1 over 2, so -3 plus 5 over 2, and y2 plus y1 over 2, 6 plus 2 over 2. That equals 2 over 2 is 1, 8 over 2 is 4, so therefore C is the point 1, 4. Just to reiterate, to find the equation of a straight line, which a perpendicular bisector is, it's a straight line, we need to know the gradient of that line and one point. We've got that point. We now need to find the gradient of the line we're looking for. We're looking for this, we'll just call this line PCQ. We know a point that lies on PCQ, which is point C. We've got that point. We need to know the gradient of PQ. Now, because PQ is perpendicular to AB, that means, so PQ is perpendicular to AB, therefore the gradient of PQ times the gradient of AB equals -1, the condition for perpendicular lines. The gradient of AB we need to determine, so the gradient of AB will be y2 minus y1, 6 minus 2 over x2 minus x1 minus 3 minus 5. So that's 4 over -8, which is -1/2. So therefore, because PQ is perpendicular to AB, the gradient of PQ is the negative reciprocal of -1/2, which is 2. So we now have the gradient of our perpendicular bisector, and we've got our point. So we can now determine the equation of the perpendicular bisector of AB. So y equals mx plus c. 4 equals 2 times 1 plus c. Therefore c equals 2, and therefore y equals 2x plus 2. And this is the equation of the perpendicular bisector of AB.